Hey, algebra students, and shout out to Caden's mom. We're going to be looking at another way to solve quadratic equations today. We have solved by factoring. In Monday's lesson, we looked at solving quadratic equations by taking square roots. But today's a really important topic. We are going to be working with the ever important quadratic formula. So I'm sure you get on the presentation. You're going to want to grab a piece of paper so you can do this warm up. So go ahead, pause the video, try these problems, then we'll come back together and go over them. All right, welcome back. Hopefully you had a chance to try these. I'm going to grab my pen and go through them with you. Maybe. There we go. All right. I'm going to go with some blue today. Oh, looks like that's what it's on. All right, so we're trying to solve this equation by factoring. I want to make sure these are in standard form. Remember, standard form should go x squared, then an x term, and then a constant. This one doesn't have a constant. So I can go ahead and factor this one using the greatest common factor. If I look, both x squared and x, or 5x, have an x in common. So I'm going to factor out an x. If I take an x out of this x squared term, I'm left with x. If I take an x out of this term, I'm left with -5. Then I set each of those factors equal to 0 and solve for x. So I have this number right here, which would be x equals 0. And the second one, I have x minus 5 equals 0. If I solve that equation, I would add 5 to both sides. And I would get x equals 5. So my two solutions are, number one, are x equals 0 and x equals 5. All right, this one, in order to get it in standard form, I've got x squared and a constant, but this x term needs to be right over here in between. So when I move this to the other side, I'm going to be subtracting 3x. So standard form for this quadratic would look like x squared minus 3x minus 10 and equals 0. 3x minus 3x is 0. So we are solving by factoring. This is a trinomial. I can factor this into, let's see, x and x. Then I'm looking for two numbers I can multiply to get 10 that are 3 apart from each other. That would be 5 and 2. Come on, pen. Hello. There we go. 5 and 2. Looks like we have some internet issues here today. Oh, come now. There we go. All right, we'll put my 2 in there. And then we have a -5 plus 2, because -5 plus 2 is -3, and -5 times +2 is a -10. Setting each of these factors equal to 0 will help me figure out my x values that make this true. So this one, I would add 5 to both sides. We just did this back here. So we have x equals 5. On the second one, I would subtract 2 from both sides of the equation, and I'd get x equals -2. All right, this third problem is a little different. It's something we're going to be doing today. You're going to have to simplify expressions like this with the plus or minus. Yesterday, we talked about the square roots. So this one, to simplify it, I would write 3 plus or minus. Hopefully you figured out the square root of 49 is 7 divided by 2. Now, I'm going to do these as two separate problems. My first one is going to be 3 plus 7 divided by 2. That would give me 10 divided by 2, which is 5. The second problem would be the negative case, so 3 minus 7 divided by 2. 3 minus 7 is -4, and -4 divided by 2 is -2. All right, let's go ahead and look at the next slide. All right, we are solving by factoring here. So this is the case where I know some of you had a little trouble with this when the first number was something other than 1. So factors of 2, we have 2x and x, then we go to the end. Factors of 5 are 1 and 5, and then you have to figure out, where do these need to go to give me an 11 for my middle term? All right, I'm going to throw 1 and 5 in this way and see if I guessed correctly. Let's see, I need a negative 11. Well, my outside, I have 2 times 5 is 10. Inside, I have 1, and I can certainly get an 11 out of that. And it looks like both signs need to be negative. Then I'd have negative 1x, negative 10x for negative 11x, and then negative 1 times negative 5 is a positive 5. So I factored correctly. All right, now remember we're solving. So I'm going to take my 2x minus 1 factor, set it equal to 0. I'm going to have my x minus 1 factor and set that equal to 0. All right, we've done this one several times now. There were 2 problems in the warm-up that had this. So I add 5 to both sides. I get x equals 5. When I have one like this, it's a 2-step problem. I'd have to first add my 1, and then I bring down my 2x. So I have 2x is equal to positive 1. Divide both sides by 2. And I get x equals a half. All right, so it is possible to do this one by factoring. Sometimes you're going to encounter polynomials that don't factor though, and that's where you're really going to want to use the quadratic formula. We could have also used the quadratic formula here. All right, and some of you may find you like it better than trying to factor these more complicated factoring problems. So the quadratic formula, as you can see, lets you solve any quadratic equation. The quadratic formula is in your journal on page 298. If you want to take a look, this is what it looks like. For any quadratic equation, the form ax squared plus bx plus c equals 0. The solutions can be found by using this little equation here. It's called the quadratic formula. So x is equal to negative b, and that b comes from here, plus or minus the square root of b squared, and that's this squared, minus 4 times a, and remember a is the coefficient of this term, times c, and c is our constant. And you'll hear people say all over, so that means this whole thing is a fraction bar, 2 times your a term. All right, so we're going to give it a whirl here. All right, so this is extra practice problem number 1. I'm going to grab my pen. So the very first thing you should do is, like when we were factoring, we want to identify our a, our b, and our c. So our a here, go back. Come on, pen. There we go. Our a term is the number in front of x squared. The coefficient here is 1. Be careful you don't put an x squared, right? These a, b, and c are numbers. Our b is a negative 10, and our c is 16. It's really important that you have the signs done correctly, all right? So we have then that our solutions are going to look like x equals, we need to do a negative b, so a negative 10. Then we have plus or minus the square root of b squared, so negative 10 squared minus 4 times a times c all over, so I would draw a really long fraction bar, 2 times a. All right, at this point, it's a matter of simplifying everything. You can grab your calculator if you need to. So first I have my negative 10, that's a positive 10, plus or minus the square root. All right, I'm going to square negative 10. Remember, we talked about this when we did the lesson on square roots. Whenever you square a negative or square a positive, you end up with a positive number. So negative 10 squared is negative 10 times negative 10 is 100. So when you're working with the quadratic formula, this first number inside the square root should always be positive. If you have a negative there, you've made a mistake. All right, then I have minus 4 times 1 is 4 times 16. 4 times 16 is 64. And again, you can use your calculator. And then I still have my all over 2 times 1 is 2. All right, I keep going. I use my order of operations. All right, I have to work inside the square root first. It's like a big parentheses. So I do 10 plus or minus the square root of, and if you do 100 minus 64, you get 36 all over 2. All right, this is kind of like that warm-up problem. Square root of 36 is 6. So my x values are x equals, I'm going to have 10 plus 6 divided by 2 is one of my answers. And I'm going to have 10, or x equals 10 minus 6 divided by 2. Right, again, we split that into two parts. That's what that plus or minus does, right? It gives us those two possible problems. So 10 plus 6 is 16. 16 divided by 2 is 8. So one of our answers is 8. Our other problem, we have 10 minus 6 is 4. Divided by 2, 4 divided by 2 is 2. So our two solutions are 8 and 2. All right, let's look at extra practice number 3. Again, I'm going to identify A, B, and C first. So my A in this case is 3. My B is -1. And my C is -2. All right, I'm going to put those into the quadratic formula. So x is equal to, I'm going to save myself a little bit of work here. When I do negative b, it's already negative. So a negative b is going to be a positive 1, right? Negative is 1, plus or minus the square root. Again, this is going to be b squared. So -1 squared is -1 times -1 is +1 minus 4 times our A term, which is 3, times our C term, which is -2, all over 2 times A, which is 2 times 3. All right, we're going to keep going. And it might help you to have the quadratic formula, like have your journal open to that page so you can keep referring back. All right, so now I'm going to keep simplifying. We have x equals 1 plus or minus the square root of, all right, we have our 1. We're going to look at this part. So 4 times 3 is 12. 12 times -2 is -24. And this is going to make it +24. Or you can think of that as this negative times this negative is going to make a positive. 4 times 3 is 12 times 2 is 24. So we have 1 plus 24. You can always type into your calculator, right? You could just go straight across 1 minus 4 times 3 times -2. All right, you can simplify it that way. Denominator 2 times 3 is 6. All right, so I'm going to keep going. I get 1 plus or minus 1 plus 24 is 25. All right, hopefully you're already seeing where this is going. All right, square root of 25 is 5. So my two x values are going to be 1 plus 5, right? Square root of 25 is 5. 1 plus 5 divided by 6. And my other one is x equals 1 minus 5 divided by 6. All right, I'm going to simplify those. 1 plus 5 is 6. 6 divided by 6 is 1. So one of my solutions, one of my x values is 1. In this case, I have 1 minus 5 is -4. 6, that we always want to try to simplify these fractions when we can, and -4, 6 can be simplified. They're both divisible by 2. So we end up with -2/3. All right, so our two solutions are 1 and -2/3. All right, let's look at another one. All right, this is number 4. So this time you have to be careful. Remember, one of the rules for using the quadratic formula was that it had to be written in standard form. All right, so this minus 13, this needs to be over on the other side, right? This needs to be equals 0. So this needs to be here. Remember, when it crosses the equal sign, the sign changes. So this turns into x squared plus 6x. And now it's not going to be minus 13 because I'd have to add 13 to both sides. So it'd be plus 13 equals 0, right? The only way we're going to get a 0 over there is to add 13. So we got to add 13 to both sides. All right, we're going to identify our A, B, and C again. Our A in this case is 1. Our B is 6 this time. And our C is a positive 13. All right, so we've got x equals -b, -6, plus or minus the square root of b squared, so 6 squared, minus 4 times a times c, right? All over 2 times a. All right, I'm gonna keep going. I'll put this in parentheses here. So we get x equals -6 plus or minus the square root of 6 squared. 6 times 6 is 36. This time I have minus, well, let's see, 4 times 1 is 4. 4 times 13, 52 looks like. All right, divide by 2. All right, hopefully you can see something that's going on here that we had in our lesson 9.3, right? What is 36 minus 52? Should be -16, right? Now, can we take the square root of a negative number? Hopefully you remember, we can't have a square root of a negative number. This has no real solutions. Okay, it has imaginary solutions, but no real solutions. All right, let's look at extra practice number 5. Again, rule number 1, get it in standard form. So I'm going to start by adding 7 to both sides. So now I have -3x squared plus 5x. And here I have -1 plus 7 would give me a +6. And on the other side, I have 0. That's what I want. All right, so we're going to identify a, b, and c. Our a this time is -3. Our b is a +5. And our c is 6. All right, so using the quadratic formula, x is going to be equal to -b, so -5, plus or minus the square root of b squared, so 5 squared minus 4 times a, and be careful that a was -3, times c, which is 6, all over 2 times a, so 2 times -3. All right, now we need to simplify all that. So I've got my -5 out in front, plus or minus, I go inside the square root, simplify that. We have 5 squared is 25. And here on this part, if I look, I'm going to have a negative times a negative is going to be a positive. 4 times 3 is 12. 12 times 6 is 72. All over 2 times -3 is -6. All right, I keep going. I have x equals -5 plus or minus the square root of, and if I add 25 to 72, I get 97 all over -6. Now, 97 doesn't have a square root, but that's okay. Remember, we had some of these the other day with the square root assignment. So one of my x values is going to be -5 plus the square root of 97 divided by -6. And that's a 9, by the way. That's really looking like a 4. And my other solution is x equals -5 minus the square root of 97 divided by -6. All right, so I need to do the numerator first. So if I do -5 minus the square root of -97, or square root of 97, I should get square root of 97 is like 9.85. So -5 plus 9.85 leaves me with 4.85 divided by 2. And again, you can check these on your calculator, or excuse me, divided by -6. This one ends up being a negative 0.81. Remember, we're rounding to the 100th place. This one, I'm going to have -5 minus that decimal number. What did I say it was? 9.85. Oh, I don't like when it gets all creepy like this. Divided by -6. That's a 5. So this time we're going to have -14.85 divided by -6. So this time we're going to get a positive answer because negative divided by negative is positive. So x, and again, remember, use the wavy line for approximate, approximately equal to 2.48 in this case. And our other one was x was approximately equal to that -0.81. All right, so this is one of my solutions, and this is one. All right, so that's one of the nice things about the quadratic formula is we can find solutions for things that can't be factored, right? We can get these nice decimal approximations that we couldn't do by factoring, right? There was no way we could have factored this. We couldn't have come up with these x values just on factoring. So it's really handy that way. All right, your assignment today is to do the quadratic formula intro worksheet, the link to the worksheets in Schoology. If you have any questions, you can send me an email. Good luck to everybody, and thanks for joining me.